Okay, so I am recording this. Okay, so this is the week 5 Math 2000 quiz help. I went to the quiz, I looked at a problem, and then I looked through the book and I said, okay, these are the closest problems that I can find. These are the closest problems that I can find that are similar. So here are the 10 problems, and we're just going to go one step at a time and do each one. Now, the first one is the easiest of them all. So I'm on page 383 if you have your book. Example 6. Now it says evaluate the following rational function. First of all, a rational means a fraction. So a rational function is a fraction with a function. This is just the symbol for the function, and we have 3x minus 1 over x squared minus 4. Can you tell me what r parentheses with a 3 in it represents? What does the r represent? I mean, not the r, but tell me what the 3 represents. No, they want you to find R3. Do you see this function over here, how it has R parentheses with an X? So this 3 really means X equals 3. Do you see how there's an X in there? So it's telling you whatever you put in that parentheses is a 3. So to do this problem, all you have to do is rewrite it and put a parentheses everywhere you see an X. And what number am I putting into the parentheses? Yeah. If we're going to use R3, it's just telling us that X equals 3. That's what R3 means. X equals 3. And we're going to do the math. So what do I get on top? 9 minus 1 is 8. Exactly. And what do I get on the bottom? Exactly, and we are done. So once again, you're going to see a problem almost identical, very similar to this. All you're going to do, whatever the parentheses in the R is, that's what X equals, and you're going to plug it in, and you're going to do the math on top. You're going to do the math on the bottom. Do not change your answer to a decimal. Don't change it to a mixed number. Leave it like this as an improper fraction. Now, if the fraction can be reduced, you reduce it. But don't change it to a mixed number. Don't change it to a decimal. So that was the easiest one. From here on, it's all downhill. Okay. So page 385. And we're doing number 15, but number 15 doesn't say domain, but the problem in the quiz says domain. Okay? So they want you to find the domain. Find the domain. Can you tell me what domain equals? What does domain mean? Well, sometimes the domain means all real numbers. But if somebody says, what is the domain? What does it really mean in algebra? Well, I'm going to tell you. Okay, this is what domain means. It's kind of something like that. But domain, this is what domain means. Domain means in algebra, what can X equal? What can X equal? And I get a valid answer. So this is what domain stands for. What can X equal and I get a valid answer? So I'm going to do a couple over here on the side before we do this problem. If I said 7 over X, give me a number for X. Just say any number. Okay, X equals 12. 7 over 12. Is this an answer? Do you see if I say X equals 12, is that an answer, 7 over 12? Okay, it's a valid answer. It's an answer. Give me another X. Hurry up, really quick. Okay, 7 over 10. Is that an answer? Is there anything I can put into x and I won't get an answer? Well, what 7 over negative 1? What's 7 divided by negative 1? That's an answer. So negative numbers are okay. 10 and 12 is okay. Let's try that 0 that you were talking about. What's 7 divided by 0? Wait, now I want you... You got your calculator with you? Oh, yeah. You come to the math class without a calculator. Now, this is really, really important. What kind of calculator do you normally use? No. Don't be buying no $150 calculator for this course. Do you have an iPhone? Oh, you're using it for this? Oh, I was going to say, look on your iPhone. 7 divided by 0, if you have a calculator, it says error. That's why I wanted you to try to type it. You cannot... 7 divided by 0 does not equal 0. 7 divided by 0 does not equal 0. You cannot divide by 0. You cannot have 0 on the bottom of a fraction. No 0 on bottoms of fraction. You've heard of undefined before? Yeah, that's undefined. You cannot have a 0 on the bottom of a fraction. It's called undefined. So, the domain for this would be domain... I'm just going to not actually write the real, but it would be all numbers. And on the number line, we call them real numbers. Are you familiar with, number line? We say all real numbers except x cannot equal 0. Do you see? If I put a 0 in there, that bottom makes this rational fraction, this 7 over x, makes it undefined. So that's not a valid answer if you put 0 on the bottom of a fraction, okay? So now I want to find the domain of this fraction. We don't care about the top. The top can equal 0. 0 over 7 equals 0. But 7 over 0 is undefined. I just want to make sure you understand the difference. 0 divided by 7 is 0, but 7 divided by 0 is undefined. So we don't care about the top. So the bottom of a fraction, a squared plus 5a... Oh, by the way, I wrote this wrong. No, I didn't. A squared plus 5a plus 6. It cannot equal 0. So whatever you get on the bottom of a fraction, you have to say that bottom cannot equal 0. Okay? That bottom cannot equal 0. That's the first thing you do. The bottom, now we have to factor. Can you factor this? A squared plus 5a plus 6. Do you know how to factor that? Do you know how we put two big parentheses and we're going to have an a and an a since it's an a square? And what numbers go in here? Okay, now be careful about that. Find all pairs that multiply together to get 6. This is a tricky one. You're on the very right path, but this is the tricky one. Things that multiply together to get 6 are 1 times 6 and 2 times 3. Okay? So you have to multiply to get this last term. 1 times 6 and 2 times 3. Which one will add or subtract to equal the middle term? Yeah, now I'm going to erase the multiplication. And do you see what you do is you just put a plus or minus in front of them. A plus 2 and a plus 3 equal a plus 5. Do you see? If you add the two numbers, it has to equal the middle term. If you multiply the two numbers, it has to equal the last term. A positive 2 and a positive 3 equal a positive 6. A positive 2 times a positive 3 is a negative, a positive 6. A positive 2 plus a positive 3, if you add it, equals a positive 5, and that's how you get it. Okay, now, so our answer is a plus 2 and a plus 3. This is our factored form, cannot equal 0. Now, just to show you, if I had this, if I had a minus 1 and a plus 5, do you see a minus 1 and a plus 5 also equals, a minus 1 and a plus 6. That also equals a 5a, right? Negative 1 and 6. But if you multiply them, you don't get a positive 6. If you multiply them, you get a negative 6. That's why you can't use that pair. Okay, so this is our factored form. Once you have your factored form, we're going to do something called the zero multiply rule. When you multiply two things together and the answer is 0, either a plus 2 has to equal 0, or a plus 3 has to equal 0. Solve for a. So how do I get a by itself on the a plus 2 equals 0? What do I have to do? Exactly, you do the opposite. Solve means get a by itself or x by itself, so I'm going to do the opposite. It's a plus 2, so I'm going to subtract 2 to both sides, and I'm left with a equals negative 2 as one answer. And here, what do I do to get the 3 to the other side? Whatever you do to one side, you do to the other. 3 minus 3 is 0. I'm left with a equals negative 3. And so my domain is, by the way, this cannot equal 0. The bottom cannot. So I still have this line through it, means cannot. So here's how you write your domain. So domain has to be in something called interval notation. So I'm going to try to raise this up. And we're going to write our domain. Uh-oh. Yeah, see what happened? I raised it up too much. I was clicking like crazy. Okay, so I want to graph this because this is the easiest way, I think, to write the interval notation that we have to. There we go. Now, here's my graph. Here's 0. Here's negative 2. And here's negative 3. X cannot equal negative 3. And it cannot equal negative 2. That's what we said, right? Now, x can equal everything else. X can equal all the stuff in between it, all these other numbers. Because all these other numbers don't make the bottom 0. I get a valid answer. Now, can you tell me what's on the far right-hand side of this number line? What's the furthest number on the right? How about yeah, you keep this arrow means it goes to infinity. Are you familiar with this symbol? Infinity is a sideways 8. Okay, and over on this side we have negative infinity. Okay, over on the other side, because those are negative numbers, we have negative infinity. Now, to write this in interval notation, you have to start. You start at negative, and you always start on the left. So we start at negative infinity, and then we're going, and we stop at negative 3. Right? Now, we jump over negative 3, and we start up again at the other side of negative 3, and we keep on going until we go to negative 2. We stop again, we jump over that hole, and we start up on the other side of negative 2, and we go all the way to infinity. This is how you write that x equals all numbers except negative 3 and negative 2. Do you see it's x equals all of these numbers. It stops at negative 3. It jumps over. It keeps on going to negative 2. Then it jumps over again and goes to infinity. Now, when we do these jumps, you'll see this. This is going to be a multiple choice question. there's these U's in the middle, meaning they're joined together. That these are just, they're called the union, and then this joining together. Okay, so this is how you would write the interval notation. Now, I just want to be careful that you know the difference between brackets and parentheses in interval notation. Do you know the difference between a bracket and a parentheses? I use all parentheses. Do you know that? Okay. Parentheses in interval notation means it does not equal the number. Do you see how we said it does not equal -3? You can never touch infinity, so you can. That's why we always have a parentheses next to infinity, because you can never touch it. We're not touching -2. We stopped on one side and then we jumped over. So these parentheses mean it does not equal. If you see brackets, that means it equals that specific number. Okay, it equals that specific number. Okay, so this is, I mean, you're gonna have this problem, and you're gonna have to pick the correct interval notation. This tells me right here that x cannot equal -3, and here x cannot equal -2, because we jumped over those numbers. We jumped over those numbers. Okay, so that was our second problem. By the way, all these notes that I'm taking right now, I'm gonna save them, and I'm gonna transfer them to you, so you'll have all these notes. Everything I write down, you'll have. So I'm on page 391, and we have two fractions that divide each other. What's the rules for dividing two fractions? Well, when you divide two, let's say I have 1/2 divided by 2/3. What's the rules for dividing fractions? Say that again. Flip what? Exactly. You flip the second fraction. So you change divide to multiply, and you flip. So we're going to do that. A squared minus 4 over a squared minus a minus 2. Change divide to multiply, and flip the second fraction. Okay? Okay, now, so we use this rule, but now you have to factor everything. So we're going to factor everything. Are you familiar with this factoring, the two-term method? See, this is a lot of stuff that we did in Math 1500 that you're missing. So factor. I'm going to do this on the side. So factoring the two-term method. When you have two terms, what you do is this is. I'm going to write this down. The two-term method. I have. What you have to do is try to make it into squares. What squared will equal 4? What can I put in this parentheses when I square it? It equals 4. What goes into that parentheses? Yeah. And then what squared equals a squared? Yeah, just a. So that's step 1 of factoring the two-term method. Once you do that, you're pretty much done. Then the second step is you make two big parentheses. Whatever was in the first parentheses, the a goes into the first spot of each. Whatever was in the second parentheses goes into the second spot of each. You see how the a is in each and then the 2 is in each? And you're always going to have 1 plus and 1 minus. 1 plus and 1 minus. This is the answer. This is the factored form. So for this top, it factors to a plus 2 and a minus 2. Okay? Now we're going to factor this one down here. This is the 3-term, just like we did the 3-term method earlier. This is a squared minus, a squared minus a minus 2. Step number 1, find all pairs that multiply together get 2. It's just 1 times 2. How can I add or subtract 1 and 2 to equal the middle term? What does it have to equal the middle term? Exactly. Make sure you put the signs, a plus 1 and a minus 2, because you need to get a minus 1 there. So my factored form is, since I have an a here, I have a, and then I'm going to use my pair, a plus 1 and a minus 2. So over here, I'm going to put the factored form is a plus 1 and a minus 2. Okay? We're almost there. I have to factor this. What method do I factor that with? I like the 2-term method that you're talking about, but do you see I can't get anything squared to equal 3? Do you see what I mean? And the a does not have a square. The 2-term, you have to have a perfect square, so there has to be a square. Okay? So if I can't use the 2-term method, there's one more method that we used in Math 1500 that you got to skip. Sometimes it's really bad to skip. Because when's the last time you've had math before this? Oh, when was the last time you had your math class before this one? Oh, okay. So 3a minus, so we're going to factor that top, 3a minus 3. And we're just going to, 3a minus 3, we're just going to factor out the greatest common factor. What can I divide out of 3a minus 3? Yeah, we're just dividing a 3. When you divide them both by 3, you end up with a minus 1. Yeah, so we just factored out the GCF out of that. So when you have 2 terms and there's no square, you're just going to factor out the GCF. So for this one, we have 3 and a minus 1. What do I get on the bottom when I factor out the GCF out of this bottom one? Yes. Okay, so step 1, we factored after we flipped everything, okay? Step 2, we're going to cancel stuff out. What's on the top and bottom that I can cancel out? Same, thing on the top and bottom. What can I cancel? Yes, as long as there's one on top and one on the bottom. That's it. Okay, so the only thing that's left is we have a 3, and I always put the numbers in. When you multiply fractions, you multiply across the top. So I'm left with a 3, an a plus 2, and an a minus 1. On the bottom, I'm left with a 2, and an a plus 1, and an a minus 2. This is our answer. There's nothing else we do. We only factor, and then we cancel. That's all you do. well, first we changed that divide to multiply, and we flipped. But then after that, all you do is factor and you cancel. Okay? Did we do, was this in the book or did I just make this up? Well, page 391, 5A. Was that? Did I write it down wrong? How come everything didn't cancel then? No, I'm looking at the answer. A plus 2, A minus 2. I think I wrote something down wrong. Oh, see what I did over here? I'm sorry. See what I did right there? There's a minus sign there. I knew I wrote something down wrong. Up here, there was a plus sign. Are you still there? Okay. And can I fix this really quick? I know we already did this. I'm just going to show you that was a plus sign. So when we factor this, since that was a plus, this would be a plus, and the other one would be a minus. Okay, so now these would cancel, and these would cancel, and we would just be left with 3 over 2. So, I mean, I really messed this up. So this is the real answer, 3 over 2. And I'm going to put a little star. I did it wrong. So just so when you go back, if you want to look at this, you'll realize that I did it wrong, but I changed it up there. So this is the real answer. But you understand what we were supposed to do. See, and I'm going to highlight what I did wrong. I want to highlight what I did wrong. There it is. Right there. That was supposed to be a plus. I wrote it down wrong when I transferred it. Won't be the first time. Should be a plus. Alright, so let's go to the next problem. I wanted to check, because normally, to tell you the truth, on the quiz, I think everything cancels out to where it's just a number. I don't remember, but I remember that from 1500 that everything almost canceled out. Okay, so problem number 4. 3 over 2x plus 5 over 2x. What do you have to do here? You're adding two fractions together. Exactly. So what do I get? What do I get? And if you put that answer down, you're going to get it wrong. Why? And what is the simplified form? Yeah, just 4 over x, not 4x. 4 over x. Yeah. These reduce. 2 goes into 8 4 times. So the 4 is on top, the x is on the bottom, and we're done. Boy, that was an easy one. That might have been too easy. Okay, so this one is a little trickier. For this one, you have to know. I have 2 terms on top and 1 term on the bottom. What I'm going to do is, when you're dividing 2 terms on top and 1 on the bottom, what you can do is you can do it twice. In other words, 4x to the negative 3 is divided by 2x to the negative 5. And 6x to the negative 5 is divided by 2x to the negative 5. Do you see I put a minus there because there's a subtraction here, so it's a subtraction. Do you understand that concept where the 2x minus 5 is really underneath both of those? Right. Okay. So now let's see if you remember exponents. Rules of exponents. Rules of exponents. I'm going to give you two different rules. Exponents. What is x to the 5 times x to the 7? What does that equal? Exactly. You add when you multiply two numbers with the same base, you add their powers. Now, what about x to the 7 over... Wait, no, let me try a different number. I'm sorry. X to the 12 over x to the 3. What does that equal? Hang on. X to the 12 over x to the 3. No, when you... Yeah, when you divide, you subtract. It's always the top. It's always the top minus the bottom. X to the 12 minus 3, so it equals x to the 9. So it's for dividing, it's subtraction, and it's always the top minus the bottom. Okay, so for this one, I'm going to do 4 divided by 2 is 2. Yeah, just 2 or 2. I'm going to say it's 2 over 1 or just 2. Now I'm doing divide here. Do you see when I did over here on x12 over x3, when you divide two numbers with the same base, the base stays the same. It stays on top. The x stays the same. So here's two numbers with the same base. The base stays the same. It stays on top. We're going to subtract the powers. It's the top power subtracted, and then the bottom power. The top minus the bottom. You see, it's always going to be the top power 12, then minus the bottom. 12 minus 3. The top power is negative 3. Then we're going to minus the bottom power, which is negative 5. And we're going to do the same thing on the other side. 6 divided by 2 is 3. And then we're going to do the power rule. The divide rule. It's the top power minus the bottom power. And the bottom power is a negative 5. So what do I get? 2x to the what power for the first one? No. That's why you need a calculator. Yes, a negative negative changes to a positive, right? So it changes to a positive. A negative 3 and a positive 5 is a positive 2. So it's 2x to the 2 power. Minus 3. Now, what do I get on this side? Yes. Now, there's another rule for exponents. What is x to the 0 power equal? What does x to the 0 power equal? It's a rule of exponents. It equals 1. Yeah. Okay. So, this x to the 0 power really equals 1. So my answer is going to be 2x squared minus 3 times, when it's really 3 times x to the 0 power. 3 times 1, which is 3. So this is our answer. You see how this changes to x to the 0 power. So it's 3 times 1, because x to the 0 power really equals 1. You see, if you had your calculator, I would have you try, what is 7 raised to the 0 power on your calculator? That equals 1. 9 raised to the 0 power equals 1. Pretty much anything raised to the 0 power equals 1. That's a rule of exponents. Okay, we're going to, question 6, we're going to solve this. I'm going to put a problem over here on the side, and then I'm going to erase it, I think. X over 2 equals... Sometimes this pen starts messing up. Equals 6 over 4. How would you work this problem, solve this problem, trying to find out what x equals? Exactly. I just wanted to make sure you knew that. I would do these two and say 4x, and then do these two and say 12. And then I divide by 4, and x equals 3. So we are going to cross multiply for this problem when you see it. So first we're going to take 5 and we're going to multiply it by x plus 5. Do you see this problem says solve? Solve means tell me what x equals. So anytime you see solve, you're going to try to tell me what x equals. Now we're going to multiply these two on the other side. Equals x plus 2 times x plus 5. So what do I get when I multiply the left-hand side? And what do I get, when I multiply the right-hand side? Hang on, I don't think I heard you right. The volume is going crazy. Yeah, that's not right. X squared. Okay, now what do I multiply? This 2, right? Now what? You can't see it? Yeah. Is it? Yeah. Are you not able to see that? Is the screen that? Oh, okay. So yeah, negative 2 times x. That's where. And then negative 2 times 5 is a negative 10. So what do I get? What's a plus 5 and a minus 2? That's okay. That's why we're here. Okay, so we ended up with this. Now, since I have an x squared, normally I want it like we did up here. You want x on one side, everything else to the other. But if you have an x squared, you need everything to one side. Everything to one side. Normally, if you have a x, just an x, you get x on one side, everything else to the other. But if you have an x squared like we have, you need to get everything to one side. So I need to take this 25 to the other side, and I need to take the 5x to the other side. So everything is on one side. How do I take the 5x to the other side? And I'm going to put that right below this. And how I get the 25 to the other side? These turn to 0. I am left with 0 on this side. And I have x squared minus 2x. Ooh, is that right? Minus 35, yeah. Okay, so what do you think I have to do now to solve to find x? What's my next step? No. What does this look like that we've done before? Yeah, you got to factor this thing. It's a three-term factoring method. So I want all the things that multiply together equal 35. 1 times 35. What else equals 35? 5 times 7, yes. And I think that's it. Which pair will add or subtract to equal a negative 2? And what signs do I use? Yes. A plus 5 and a minus 7. And when you add those, you get a negative 2. Do you see when you multiply them, you get a negative 35? When you add them, you get a... Sorry, this pen's not working 100%. When you add them, you get a negative 2, and when you multiply them, you get a negative 35. So we put this in our factored form. The x and the x in the first spot, whatever's this goes in the first spot, and then we use our pair. A plus 5, it doesn't matter which one goes first, and a minus 7, just as long as the 5 is the positive and the 7 is the minus. I said this is a 0, not an A. Okay, now what do I do? We still have to find out what x equals. Okay, so we did this one time before. The 0 multiply rule. When you multiply two things together and the answer is 0, if I put a 5 here, what has to be in the other parentheses? Yeah, that's the 0 multiply rule. Do you see I'm multiplying two items together and the answer is 0. So one of these two have to be 0. The x plus 5 has to equal 0, or the x minus 7 has to equal 0. If you multiply two things together and the answer is 0, one of these has to equal 0. And you just solve for x for each one. Boy, did everything just go away there. Come on, is it going to come back? It's not coming back. That's so weird. Just the plus sign. That should be a plus sign. I don't know if you're seeing this big mess here. Where's that? There we go. Okay, so I need to get the 5 to the other side. How do I do that? Yep. And we get x equals 0 minus 5 is a negative 5. This is one of our answers. And I need to get the 7 to the other side. Well, this is a plus 7. So you do the opposite. Yeah, so we're going to subtract 7 to both sides. And we get x equals negative 7. These are our two answers. X equals a negative 5 and x equals a negative 7. No, because see, that's when they were asking for domain. They asked for domain. Here, they just said solve it. Solve means tell me what x equals. So this problem just says solve. So you see the word solve. Tell me what x equals. That's what solve means. Tell me what x equals. And now the other one that you're talking about was domain. Okay, we are in trouble for this one. What happened here? Oh my God, can I erase all this? It's like the page is bleeding over or something. How is that even possible? How is that possible? Okay, so we're on page 412. I think this is the craziest problem of them all. And it just says, what problem are we doing? Number 21. It just says simplify the complex fraction. So complex fractions are just fractions that have fractions. So I'm going to just look at the top first. We want to find, we're just looking at the top part. So we want to find the lowest common denominator for the top. And we always ask yourself, to find the lowest common denominator, when we have all these x's like this, just x's without numbers, you always ask, what is the highest power x? So you're always asking, what is the highest power x? So when I look at this top part and just looking at their denominators, what's the highest power x you see down there? Yeah. Okay. Now, since we have more than one letter, what's the highest power y? So this is our LCD, our lowest common denominator, x2, y3, okay? You always ask what is the highest power x in whatever letter we're talking about. This is my LCD. You're going to multiply each by that, each fraction by your LCD. So watch what I do. I'm going to just do the top here. 1 over x squared y squared times my LCD, which is, and let me change my color for my LCD, which is x squared y3. And then I'm going to add the other side, 1 over x y3, and I'm going to multiply it by the common denominator, x squared y3. Okay? So multiply each fraction by the x squared y3. Do you now cancel? I guess I could put this is step 1, this is step 2, this is step 3. Cancel. And you see how the x2's cancel? Now the y2's cancel, but what happens when I cancel the y2 with the y3? Do you see how there's still one y left over? So you can cancel any top with any bottom. The x2's cancel, y2, y3. Or you could look at it like this. y3 over y2, remember you subtract them. 3 minus 2 is y to the 1 power. Okay? Now on the over here, x and x2, there's an x that's left over. Right? And then the y3's just cancel. What's left on the first fraction? What is left on the first fraction? No, those were canceled. The x squared, y squared, those were canceled. What's the only thing? What's left on that first fraction? Do you see the only thing left? Yeah, the only thing left is the y on top. So we're just going to put a y. There's nothing left on the bottom. So, you can put y over 1, but that's just y. What's left on the other fraction? Exactly. So that's what our top looks like. Do you see? This top changes to y plus x by multiplying by the LCD. So we're going to do the same thing to the bottom now. I'm just waiting for this. I'm just waiting for my mouse to. There it goes. So we're going to step 4. Uh-oh. Do the same to the bottom. I don't know why this happens, but this happens a lot when after about an hour. I don't know why. I have no idea. Hang on, let me see if I can move this thing and clear this up. Uh-oh. I didn't want to do that. There we go. There we go. So we want to do the same thing to the bottom. Let's see if I can get this back. Okay, we're back. And the bottom is 1 over x3 y. Oh well, let's do the same thing to the bottom. LCD. What's the LCD? Look at the bottom up here. What's the highest power x? And what's the highest power y? Y to the 1 power. Yeah. So my LCD for the bottom is x3y. So in other words, I have my x3y here. I'm going to multiply it by my LCD. I'm changing my LCD to red so we understand that. And we have the LCD is x3y. And then we're going to subtract it. And we have 1 over xy. And the LCD is x3y. Let me change the color, and it's going to let me. There we go, x3y. Now, on the first fraction, yeah, and the y's actually cancel out too. You see there's a y on the bottom and the y on the top. What's left on that first fraction? What's left on the first fraction? Yep. Now the second fraction. The x cancels with the x3. What do I have left? X squared, exactly. And then the y's cancel, and they just go away. So on what do I have left on the second fraction? Yes. Okay. So I'm going to try to. This thing is not cooperating. I want to try to lower it. I think what I'm going to start doing is using a different thing that I use. I actually use a different site sometimes. So okay, I'm going to put the answer over here. So on the top we have y plus x. On the bottom we have 1 minus x squared. And we're done. Yeah, but just looking at the original problem, it's pretty scary. most people say, what? No, I'm skipping that one. Okay, so this next one, this is page 417, example 3. Page 417, example 3. So we're going to do long division. So it's up here, but I'm not going to move it. It's going to mess me up. So this is page 417, example 3. And it says, find the quotient and the remainder. What does quotient mean? Exactly. Quotient means divide. It's the answer for divide. So to divide this using long division, have you ever done long division with this stuff before? Okay, this is going to be a treat then. uh, um, see, the x minus 2, whatever you divide it by goes on the outside. The x squared plus 3x minus 9 goes on the inside. Okay, so watch this process. It's really hard for me to write this down, so I'm going to try to use arrows and stuff. On the side, we need to take this and this. So on the side, I'm looking at x squared divided by x. So this is I'm just putting a little 1 here. What's x squared divided by x? Yes. In other words, there's just saying, if you remember dividing, how many times does x go into x squared? The answer is x. Now, when you divide, you have to have it in the right column. This is the x squared column. This is the x column. So we're putting the x up here, underneath the x column. X goes, so we're putting that x underneath the x column. It's kind of important. So when you did that, when you do long division, let's say I had 642 divided by 8. 8 goes into 6. No, 8 goes into 64 8 times, right? And then you multiply these two together. 8 times 8 is 64, and you subtract it. Right? Are you familiar with that? Okay, so we're going to multiply this together. We're going to multiply. Watch what happens. X times x is x squared, and x times a negative 2 is a negative 2x. Right? Okay, now what do we do up here after we multiplied it? Wait, no, what did we do up here after we multiplied? 8 times 8, I got 64. What did I do next? Exactly. So we multiply, then we subtract. So I'm going to subtract here. When you subtract, you put it into parentheses, so you have to distribute the negative sign. Negative negative changes to a positive. Do you see how I'm doing that? See, it's really hard for me to write this down like this, but I'm trying. Let me see if I can erase that. There we go. So we end up with x squared minus 2x. I'm trying to. Okay, there we go. We got it. So then we're going to subtract. But you have to subtract here, which is changed to here, and then here we're going to change the negative to a positive. You see how I did that? And then we add them up. X squared and x squared. Instead of subtracting, we're just going to add them. I guess you could say you're subtracting, but I like to say I'm adding. X squared minus x squared is 0. Do you see how I have a positive x squared and a negative x squared? And then what's 3x and a plus 2x? Exactly. So we get 5x there. And then we bring down the minus 9. Okay, now I ask again, how many times does x go into 5x? So down here we have, just like we had x squared on top, we have the 5x, whatever's over here on top, and then the x goes underneath it. How many times does x go into 5x? Yeah, because the x's just cancel. So we put a 5 up here, a plus 5. And then we multiply again. 5 times x is 5x. 5 times a negative 2, negative 10. And then we subtract. 5x minus 5x is 0, and so I'm not changing the sign this time. a negative 9 minus a negative 10. I think that confused you up there. A negative 9 subtract a negative 10. What do I get? A plus, yeah, a plus 1. I'd have a 9 plus 10, which is a positive 1. So I'm just so it doesn't make it too confusing over here. I'm gonna I don't know if I can erase all this because this thing's not letting me do anything. There we go. So this was x squared and then a minus 2x. And then we just took the negative sign and we subtracted it. And we ended up with 0 here. And then a minus minus changed to a plus. I'll put that there. Okay. So this is our answer. This problem says what's our quotient, which is x plus 5. And then we have a remainder of 1. This was our answer. It says what is our quotient and what is our remainder. X plus 5 with a remainder of 1. Okay? Now, we're going to do this long division 2 more times. The last 2 problems are long division. Now, this problem says use synthetic division. Now, even, the quiz says use synthetic division. You're going to find the answer. I'm not going to teach you synthetic division. That's another way of dividing. I'm going to go ahead and use the long division that we just did, okay? So this is 2x to the 4th. Now, watch what I do. I have x to the 4th, then I have x squared. I'm missing x to the 3rd, so I'm putting plus 0x to the 3rd, then minus 5x squared plus 6x minus 9. You have to fill in every spot. So did you see how I filled in? I'm going to put a little line underneath this, if I'm able to. That I added that in there. I added that in there, okay? And we're going to divide this by x plus 2. And we're going to go through the same process. How many times does x go into 2x to the 4th? How many times does x go into 2x to the 4th? X to the 4th. Let me. I'm a little bit. That's x to the 4th over. You just have to divide that. Even though I say how many times does it go in there, you have to go through that divide process. That divide process is, 2x to the 4th divided by x equals 2x to the 3rd. You see, the 4 minus the 1 power equals the 3 power. Do you understand that? That exponent rule, when you're dividing, you subtract 4, and the x by itself, there's an invisible 1 there. So we have 2x to the 3rd that goes up here. And do you see how it's right underneath the x to the 3rd column? And then we're going to go through the multiply. 2 times x to the 3rd, you're always going to end up with this number over here. Let me change my color. We get 2x to the 4th. 2x to the 3rd times 2, I get plus 4x to the 3rd. And then we subtract. These two cancel and turn into 0. 2x to the 4th minus 2x to the 4th. 0 minus 4x to the 3rd equals... It's 0 minus 4 is a negative 4. You see, it's the top minus the bottom. 0, you have to use this subtraction sign. 0 minus 4 is a negative 4x to the 3rd. The x to the 3rd is not going to change here. We're not dividing, we're subtracting now. Okay? So then we bring down the next number, which is minus 5x squared. Uh-oh. Give it a second. It'll come back. It's supposed to come, but there it goes. It's back. Did I just write the same? What happened? I didn't write that same thing twice. Or did I? Remind me in next week. I'm going to try to use the other. I've been saying that I'm going to try to use my WebEx account. So I actually like this account just for one particular reason. It transfers files very easy. Okay, I'm just waiting for it to catch up. It's boy, come on, it's still messing up. Okay, let's see if we can. I don't know if we can work from here. Let me see if I can go to home and stop everything. There we go. Okay, so we did that. This all started when I downloaded my new Microsoft Office. I don't know why. Everything was fine until I messed with that new version. I don't even see my pen anymore. Insert. Where's the pen? Maybe I have to take it out. There it is. Okay. What? There. Now my pen's not even there. It's staying. Okay, I'm back. So we brought everything down. Now we're going to find this. We have a negative 4x to the third, and we're going to see how many times x goes into it. And what's the answer? Yes. And I'm going to put it in the x squared column, negative 4x squared. And then we're going to go through the multiplication. 4 times x is a negative 4x3. Negative 4x2 times 2 is a negative 8x squared. And then we're going to subtract them. A negative 4 minus a minus, which is a plus. Negative 4 plus 4 is 0. The first number should always turn out to 0. Now, what's a negative 5 minus a minus 8? X squares. Yes. Then we're going to bring this down, plus 6x, and we're going to go through that whole process again. Let's see if I have a different color. I don't know if this color even works. And so then I'm left with 3x squared, and it's going to divide by the x. And what do I get? So I'm going to put a plus 3x in the next spot and go through that process. 3x times x is a 3x squared. 3x times 2, which is a positive 6x. Then we're going to subtract. Uh-oh, I went too high. We subtract. We're not just subtracting one term, we're subtracting both. 3x is 0, 6x minus 6x is 0. But we're not done, because we still have to bring down that minus 9. That minus 9 comes down. But normally we say, how many times does x go? You know, normally we have an x here, but we don't. You know, how many times does x go into negative 9? It doesn't. So we're actually done. We're actually done. This is the answer, 2x to the third minus 4x plus 9. Now let me show you another way of writing the answer. Our remainder is a minus 3, or a minus 9. So you can put a minus 9 remainder over the quotient x plus 2. So I just wanted to show you that in case our remainder, they might just say the remainder of minus 9, then you got it. But they might have it in this form where you put your remainder minus 9 over your quotient, the x plus 2. Okay, so we could go either way in that. And we are on our last problem. Whew, we're at 1 minute and 1 hour and 10 minutes. We should be done in an hour. Oh, is this the last problem? It's not even a. Oh, good. It's not even a long division. All right. To solve this, step number 1: find your lowest common denominator. What's the common denominator here? No, I have an x. I have an x plus 2, and I have a 1. It would be x and x plus 2. Oh, now, if I'm going to erase this, but I'm going to show you. If I had 1/2 plus 1/3, what's the common denominator? One half plus 1/3. What's the common denominator? Because you multiplied the two together, right? Do you see how I just multiply these two, x and x plus 2 together? That's my common denominator. See how I got that? Okay. So, step 1, find the LCD. Step 2, multiply. Uh-oh, hang on. My screen's going dark. Give it a chance. It doesn't like me to write on this right pad for more than an hour because I'm using a lot of memory up. Step 2 is multiply each term by the LCD. We're going to multiply each term by the LCD. So, exactly, I'm going to do 10x, and then I'm going to multiply it by the LCD. Not just each side, but each term. And I'm going to multiply this by x times x minus 2. Then I'm going to go plus. Yeah, it really doesn't want me to write anymore. We're on the last problem. Come on. Let's see if we can get this down. Hang on. Those dogs outside are barking, driving me crazy. Okay, let's see what we can do. Hang on, give it a second. It's got to catch up. Okay, so we're going to multiply this by the x and the x minus 2. Then I have a plus 14 over x plus 2. And then I have a 4 over 1. And I'm going to multiply all of these by the x times x minus 2. X times x minus 2. X times x minus 2. And watch what happens. These x's cancel, and I'm left with 10 times x minus 2. What do I get when I multiply 10 times x minus 2? Yes, you distribute, and you get 10x minus 20. Here, I'm going to cancel out the x minus 2's. I'm left with just 14x. Do you see how that worked? Now here, I'm 4x times x minus 2. Nothing cancels. So I'm going to distribute 4x to each of these. 4x times x. What's that equal? Yeah, 4x times x is 4x squared first. Right? X times x is x squared. And then 4x times a negative 2 is a negative 8. So we have normally if you have x's, you get x's to one side, everything else to the other. But I have an x square. So I want to take everything to one side. This should be an 8x. There we go. First I'm going to add these two together. 10x and 14x is 24x. And I have a minus 20. That's a positive 24x. Okay, now I need to take the 20 and the 24x to the other side. I need everything to one side. How do I take the negative 20 to the other side? Add 20. Add 20. That's supposed to be a 8x. I wrote it twice and it still didn't take it. There we go. Well, if I write one thing, the other one cancels. How is that possible? I don't think I'm going to change color anymore. I added 20 to both sides. I added 20 to both sides. Okay. Now, what else do I have to do to get this 24x to the other side? Subtract 24x, and I'm going to subtract 24x. On this side, I get 0. On the other side, I get 4x squared. What else do I get? What else do I get? I get 4x squared. What else? No, a negative and a negative, when you combine them, you have to add them. Negative 32x. Negative 8 and a negative 24 is a negative 32x. And then you have a plus 20. Okay, and now I have to recognize that each of these divide by 4. Do you see how they all divide by 4? So and I can divide the 0 by 4. I get 0 equals x squared minus 8x plus 5. I just divided everything by 4. Now, I have no idea what I did wrong. I think with all this pen messing up, something went wrong because I can't factor that. What number are we on? I didn't even look this up. What number are we on? I messed up somewhere because it's not factoring right. Example 2. Okay, so something happened. When all my pen was messing up, something happened because we don't have the right answer. 4x squared minus 16x minus 20. We have 4x squared minus 8 or 32x plus 20. Unfortunately, we didn't get the right answer here. I think it was my pen messing up too much. But our common denominator, I'm looking at page 426. I'm looking what we did, and we ended up with 10x plus, see, that should be a plus 20. Oh, the LCD, you see what happens is, when I put a plus, half of it goes away, so I think I had a minus. These should all be pluses. That's the bad thing about this pen. That part goes away, and I don't realize it. So we had to multiply. These canceled. This ended up being a plus. What else changed? This ended up being a plus. I'm gonna go ahead and cancel all this, and I'm going to look in the book. This is what we should have gotten. We should have gotten 0 equals negative 4x minus 5 after we divided by 4. After we divided by 4. And then, see, once again, I wrote it, and it's erasing. I wonder. I think next week I'm going to try my other computer. I'll try. Something is not right here. I don't know if it's the Join Me or the other. Maybe I'm gonna try the other program next week. Okay. I'm lost again. Minus 4x minus. It should be x. Hang on. Yeah, it's not letting me write at all anymore. So I'm just going to put on it's on page 426, the end of it, where we have to factor it again. Now it's writing. No, we have to factor it and then solve for x. And it said x equals 5 and x equals